Hi, today we're going to do something a little different now that we're done with the matter portion of the year. I wanted to take a day and talk a bit about the Regents exam, how it's structured, and some tips for how you can answer it. So as you can see here, here's the breakdown. This is a copy of the front cover of the January Regents, the most recent one. The total is 85 points, and as you can see, there's 50 points total there, so that in parts B, 2, and C, there's a total of 35 points. The actual breakdown is not always fixed to the best of my knowledge. Sometimes it's like 15 and 20 or like 17 and 18, so I didn't want to put numbers there. But you can see that each section is structured slightly differently, with the first two being multiple choice and the second two being a free response section. So there's your breakdown. I'll let you read that. You can hit the pause button. You can go ahead and see what each part has to do with, but we're going to take a look at some practice questions anyway, so we'll get to that in a bit. Once you get your score out of 85, there's a conversion that happens, and I copied the top part of the conversion from the January 2020 Regents, so you can see a raw score of 85 is obviously scaled to 100. You get, a perfect score, If you go and do the math, you can see that it is a scaling. That is to say, it's not linear. 84 out of 85 is actually greater than 0.98, I believe. I can grab a calculator just to be 100% sure about that. But, in the time it's taking me to calculate, I think you're getting that too. Yeah, 84 at 85 is technically a 99, so the scaling just shows that it's not 100%. A 63 out of 85 would be 74. So you can see, sometimes the scaled score and the raw score are not exactly the same, which is fine. I mean, the state makes the rules. The state says, this is what the score ends up being, and that's what the conversion allows for. The state says, oh, well, I want the distribution of scores to look a certain way, so that's why that scaling exists. We can dig more into this as we get closer to June. I just wanted to let you know that that conversion exists. Couple tips about answering multiple choice questions. The first thing I can say, and I cannot stress this enough, when it comes to multiple choice questions, the Chemistry Regents likes to ask questions that assess whether or not you can translate and whether or not you understand vocabulary. So you'll see a question like the one to the right of this first bullet where you can, if you know what these terms mean, it actually goes a long way towards just quickly getting a correct answer. Amount of energy to remove the loosely held electron from a gaseous atom in the ground state, that translates to first ionization energy. Now, we haven't talked about that yet, obviously, but we will. It's coming up very soon. But that quick translation says which element requires the least first ionization energy becomes a lot easier because that's found on table S of your reference table, and you can just look it up. It's the numbers are right in front of you. Secondly, the answers will be significant figure accurate. And again, this is stuff that's to come. But as you can see, the question has 1 gram, 1.00, and all three of the answers have 3 non-zero digits in them. A lot of times when you are doing a problem, the numbers that you're given may not be exactly. When you do the math, you might get a number that isn't shown in the answers, but when you round your answer, you'll get one of the answer choices. The Regents likes to do this. They like to make sure their numbers have a certain amount of data in them, and so there's some rounding rules at play there. And then finally, one of the biggest hints I can give you is don't be afraid to treat the test like Sesame Street. One of these things is not like the others. That said, you might need to know a little bit about chemistry to determine that. For example, the first set of 4 answers, covalent, ionic, and metallic, are types of bonding where hydrogen bonding is actually intermolecular force. So I'm going to guess that 2 is the correct answer without even seeing the question. For the set on the bottom, oxidation reduction, single replacement, and substitution are types of chemical reactions where transmutation is a nuclear process. I'm going to guess the answer is 4 without seeing the question. Sometimes this works. Sometimes, like the final set of 4 questions, the answer choices don't really give you much information at all, so I can't really just guess without seeing the question. But what I'm saying is if you're really in a pinch, and you don't know what to do at all, sometimes knowing enough about chemistry to just guess the one that doesn't fit is enough to give you the correct answer. But the main point of this video, I wanted to dig in a bit to the free response questions. So I'm going to talk about some strategies there, and then I'm going to go through a couple. Tonight you're going to go through a couple more of your own. My suggestion about answering free response questions to save a little bit of time is actually to read the questions before the passage. I know, controversial opinion, because a lot of teachers may disagree with me on this one, but look at the question that's there. I can answer that question without having done a reading from the passage first. This is, again, not 100% the case, but if you read the questions first and you feel like you can answer them without reading the passage, you just save yourself some time. I think I can solve this with just looking at my reference table. The second thing I can say is that you will get certain prompts in your question to tell you what your answer needs to look like. So if it says, in terms of, in your question, whatever comes after that in terms of better be in your answer. And I'm not saying answer by saying in terms of particle size. No. I'm saying particle size should work its way into your response. Particle size, you're getting prompted to think about particle size. So that's kind of like nudging you in the direction of an answer. And if your answer does not even begin to address particle size, you're not going to get points. It's going to be a lot harder to find points there. In terms of collision between gas molecules and the walls of container, like again, it's kind of like really pushing you in a direction. And then secondly, when you see these words, identify, explain, compare, calculate, state, they're actually asking you to do different things. And explain is a why question, which would require like the most information out of you to come up with a correct response. When you see things like state is just a fact. One is bigger, one is smaller, it is blue, it is sodium. Like very short answers are coming out of that. Comparison, again, is not a why question, it's just this is what it is. Calculate means that you're going to get, a numerical answer. There's probably going to be math involved. And then the last thing I can say about free response questions is I don't know what everyone's experience has been with, say, the biology Regents or the earth science Regents. I know for the biology Regents, sometimes you're being asked to write like a paragraph of information. That's not the case here. Most of these questions are solvable with a single sentence, maybe 2 sentences. Sometimes you can get away with a phrase. You can see this is one set of answers here, and then this is a second set of answers. I think for the second set of answers, if you had just said one less electron, borderline would get you credit. Now, I'm not saying I'm not saying purposely be overly concise, but again, saving you time allows you more time to think, more time to check your work, and to avoid everyone's big demon when it comes to tests, from what I've heard, mistakes, silly mistakes. The more time you have to look back over something, the less you make silly mistakes. So, if you are interested in attempting these problems yourself, hit the pause button, look at these 4 questions, go ahead and try and answer them. I'm going to go through them now, but I want to give everyone the chance to attempt them on their own if they choose. Looking at X, types of mixtures, we know homogeneous. There's another type. This would be the other one, heterogeneous. And again, it says what, not why, so we can get away with a very short answer. What's represented by Z? Z substances are broken down into 2 categories, elements and something else. Well, if it's a substance, we know substance means pure. There's your word translation, and compounds. Okay. So explain in terms of particle arrangement, why. So you see the word explain and why coming together. In terms of particle arrangement, why is it homogeneous? Well, I know in general that homogeneous mixtures have uniform particle distribution. Again, like we know, like when you have a solution, sodium chloride aqueous, the salt is evenly spread out through the water. You don't have clumps of salt at the bottom because that's not homogeneous. That's not a solution. It's not dissolved. So did I specifically say particle arrangement? No, but I addressed particle arrangement by talking about distribution. That's close enough. Given a mixture of sand and water, give me one process. Well, again, that's nothing to do with the picture up here. I know sand and water, that sand doesn't dissolve in water, so it would be sinking to the bottom, which means it has bigger particles. So this would be filtration would work. Could distillation work? Maybe, but filtration is definitely the better option. One question here, so I'm going to start, like I said, by reading. I'm going to start by reading the question. Identify a process used to separate the components of natural gas. Okay. Well, the data table, I'll go back there. It says natural gas. Here are some components. All right, that's useful. I think maybe I should just read the prompt to be sure. Natural gas, a mixture of those things. Differences in boiling point can be used to separate the components. Oh, well, they're telling me what's the difference and what can be used. So really the question's saying, what process uses difference in boiling points? And I know that the difference in boiling point, the process that best exploits that is distillation. In a lot of these part 2 questions, there's usually a set of questions. Some of them will address parts of the reading, some of them may not, like you saw in the previous question. They refer to the table, they don't. So this is one of those cases where I can just pull one piece of information and I'm good. And then finally, here's a question about air, I believe. Nitrogen and oxygen make up 99. Oh, wait. Explain why the atmosphere is classified as a mixture. Can I answer that? Well, I mean, I can say that there's several substances present. I know that. But even if we dart back to the reading really quickly, the second sentence actually tells me that. So, are several components not bonded? So that's one possible answer. I think a different possible answer is the next sentence. The amount of carbon dioxide can vary. The makeup. I'm not saying that you have to write both. I'm just showing that there are 2 different answers to the same question. If I wanted to, I could totally refer to the reference tables, but I don't think I need to because I think I actually answered the question. I hope this clarifies things for everyone, that you feel a little bit better about seeing this large test at the end of the year when the time comes. Thanks for watching.